Okay, so here's where I'm going to go over what you can expect on your test. Remember, the first 10 questions are going to be multiple choice. You get a calculator on every one of these. Okay, the first one, it gives you relationships, and you have to determine which of those is linear, which is exponential. So make sure you can tell by reading a situation which one fits what kind of relationship. That's number one. 2, you're given a graph and you're asked to match it with the equation, kind of like we did on Thursday and Friday of last week when I was still here. So it's important to know the y-intercept, figure out what's the rate at which we're being multiplied every time. Did the horizontal asymptote shift up or down? Is it a growth? Is it decay? Has it been reflected? All those things. 3, you're going to be given an equation, and it wants to know, like, what are some characteristics of that equation? So, like, which of these match with it? And again, it's a A, B, C, D. 4, you're given an equation, and we want to know what does, like, certain parts of that equation represent. So, like, if it's in the form of A times B raised to the X, what does the A represent? What does the B represent? Five, you're given an equation, and you are asked to find the average rate of change between 2 points. So hopefully you're trained now to, when you hear average rate of change, you know what to think of. Slope. 6, you're given a situation that's being modeled. Read about it. It's got a little bit of understanding. Then it talks about an equation. Then it wants you to know which statement is false. I'm going to tell you, be familiar with all of our half-life stuff that we did. So I'm looking at 7. 7 is tricky. But I don't think we've done anything like that. Give me just a second. So we haven't. So in just a second, I'm going to go do a little bit of a review about something similar to 7. So just hang tight for 7. Eight, you have to know about how functions work, substitution, and you must also know your exponent rules. You're going to be simplifying an equation. Nine's tricky too. So here's what I think's happened. I think that some of this test, I know that they talked about this, that this unit used to be logarithms and exponentials all together. Some of this stuff that they have showing, it is an exponential function, but they're asking questions that we haven't went over yet. So I'm going to go over parts of number 9. 10, you're given a table, and you're asked to explain what some characteristics of the function from a table. You should be good with 10. So 7 and 9, I've got a note to look at. Those are all with a calculator. And then section 2, which is the free response, I'm looking at the one with a calculator. That's just a substitution. That one shouldn't be a problem. Limit notation. Anytime you see limit notation, you should automatically be thinking we're talking about end behavior with B. So I'm looking at an exponential function and what its end behavior is. So what it does at extreme values. So think about the possibilities, and remember we do have a horizontal asymptote for exponential functions as well. C, you're asked to find a specific temperature of the situation. So that is making sure you know which variable represents what. So make sure you know, am I plugging in for X or Y? And then D's a good one. We haven't talked about something like D's explicitly, but it's one that I would expect you could see something like that on the test. So I'm going to leave D out. And then the ones you have to do without a calculator, you're given an equation. Remember, how do we find intercepts? We find an x-intercept by plugging in 0 for y. We find y-intercepts by plugging in 0 for x. So remember that. Limit notation, again, so we're talking about end behavior. You're going to be asked to find the domain and range of an exponential function. We did some stuff like that my last day I was here on Friday. So you can look back at that lesson. And then it wants to know, is this an arithmetic sequence or a geometric sequence? So make sure you know the difference between them. And that's the no calculator portion. All right. I'm fixing to work some like 7 and 9. So let's go there now. So I'm going to start with the one that's similar to number 9. Yep. Okay, so if we're looking at something, this is something similar to number 9. I'm going to start with an easy version. If I said 3 to the x was equal to 3 to the 5th, and you have to solve for what is x. We can see there that x would have to equal 5. We can set the exponents equal. When the bases are the same, they're both 3's, we can set the exponents equal. That seems kind of dumb and easy, I know. Right, but now what if I had this? 3 to the x was equal to 9. Again, this one might seem easy enough to you because you know what this one has to be. But if you didn't know, one of the options is you could rewrite this. 9 is the same thing as 3 to the 2nd. And so now then they have the same base. So we can set the exponents equal. Another idea here, so let me make it a little bit more challenging. If I had 4 raised to the 2x was equal to 16 raised to the x minus 1. Okay. Can I rewrite both of these with the same base? We could. 16 can be written as 4 squared. So this would be 4 squared raised to the x minus 1. And so now I have a power raised to a power. Anytime I have a power raised to a power, we multiply. So this is 2 times x minus 1. If I distribute there, that is 2x minus 2. So again, I just made these up, so this isn't going to make any sense. The number answer is going to be nonsense. So look here, I made the bases match, which means we set the exponents equal. So 2x must equal 2x minus 2. And then we could solve for x. Like I told you, this one was a bad example. I get 0 equals negative 2, which is nonsense, which means there is no solution. Let me do another one similar that maybe has a solution. So if I tried this one, 5 to the 3x is equal to 25 raised to the x plus 2. So now let's rewrite them. We could rewrite 25 as 5 squared, raise that to the x plus 2. When I have a power raised to a power, we multiply. So that's going to leave me with 5 to the 3x on the left equals 5 raised to the 2x plus 4, right, once I distribute there. So now the bases match, so we set the exponents equal. If I do that and I solve, that tells me that 1x equals 4. So there was only one solution, and that one solution is x equals 4. So your number 9 is similar to these. Okay, and then number 7. 7 is a factoring problem. I'll probably do 7 as some type of bonus, just to be honest, because it's so far out there from something we haven't even talked about yet. I feel bad putting it on this test. So go back and do 7, and I'll be here Wednesday to tell you this. You can go back and do 7 as a bonus last, but that's crazy to me. Let me find a similar example. If I'd have had my first week, when we did all the factoring review, I go over this during the factoring review. But it's, again, I feel bad that I didn't get to do that this time. I'm just going to make something up. Okay, this may not factor. I can make it factor. I can do this. Okay, if I have 4 times 2 to the 2x plus 5 at the end plus 12 times 2 to the x. Okay, if this is my equation, it wants me to factor this. Or it doesn't tell me that. It just says how many solutions are there. When I look at this, I see very clearly to me, this is something that's like ax squared plus bx plus c. It's in that trinomial form. So if I had to factor this, it's really confusing with all of this garbage as my variable. So we use what's called a u substitution. So I'm going to let u be equal to 2 raised to the x. Because right here, look at this first one. I could rewrite 2 raised to the 2x as 2 raised to the x squared. Remember, these are being multiplied. So because exponents here are multiplied, they were originally written as a power to a power. So again, you need to know those exponent rules again. So if I wanted to, I could rewrite this as 4 times 2 to the x squared plus 12 times 2 to the x plus 5. Now it looks even more like a trinomial. And then we would use this u substitution, which means everywhere I see 2 raised to the x, I'm going to substitute in a u. So this becomes 4 times u squared plus 12 times u plus 5. And then we have to factor this. So for me, this is an a times c problem. So 4 times 5 is 20. What multiplies to be 20 but combined is 12? That's going to be 10 times 2. So I can rewrite this as 4u squared plus 10u plus 2u plus 5. And then I group. And this has a GCF of 2u, which leaves me with u plus 5. This one has a GCF of 1, which leaves me with 2u plus 5. And so I am left with what's in front of the parentheses, 2u plus 1 times the matching parenthesis, u plus 5. Okay, and then if I solved, 2u plus 1 equals 0, and u plus 5 equals 0. So that means that, again, 2u equals negative 1, which means u equals negative 1/2, and this says u equals negative 5. But the problem is I didn't start with a u. I started with a 2 to the x. So I'm going to take 2 to the x and plug it in for u. So this becomes 2 to the x equals negative 1/2. And in the other one, 2 to the x equals negative 5. And then we'd have to solve these. So moral of the story is I've not shown you anything like this. This is definitely coming in the logarithmic functions when we get there. I would think these are very common pre-cal problems, but they're not anything that we've covered yet. So the more I work these out, I think I'm going to say 7 and 9, you're just going to not work those. Because it's not fair to you. I don't know why I went through and showed you all this. Hopefully you stopped yourself before you got to the end of this video. Because I feel confident we're going to test that stuff later. It's not something we've covered yet. But hey, maybe I at least made you panic for a little bit. That's good. And maybe you'll have a heads up when we get to this kind of stuff next unit.